Yeah, so today we have Mugdha Polimera. She comes from us from right down the hall here, ADS SciX. SciX officially now.
Yes.
We've been here for 2 years, and before that was at UNC Chapel Hill, doing a PhD program. And I guess you're going to tell us today about AI ML enhancements to the ADS and SciX processes. So, take it away.
Thank you, Josh. Good afternoon, I guess, everybody. I'm Mugdha Polimera. I'm on the software development team at ADS and now SciX, and I'm excited to share with you what all things we're doing behind the scenes that you may not associate ADS and SciX with. So just, I'm sure most people here are familiar, but just as an intro, ADS, the Astrophysics Data Systems, is a NASA-funded project. We've been around since 1993, so we're a little over 30 years old now. And our entire system is centered around scholarly literature. So it means it starts with papers, and then we associate whatever data that we can manage to associate back to that. Citations, references, softwares, data sets, all kinds of things. So it's a fun little timeline in 94 when we started. This looks like, very, very early internet kind of geeky form. In 2018, it became a little less early internet, but still geeky. And then in 2019, we introduced the modern form, which just takes you to the single search bar and does all the kind of fielding and complicated search behind the scenes. And so ADS is frequently referred to as a digital library, which we are. But in this evolution over 30 years, we have evolved to something more than just a digital library. So we have officially launched SciX, the Science Explorer, which is the expansion of ADS across all Earth and space sciences. So Earth science, which really is a catch-all term for everything you know about the Earth. So like volcanology, glaciology, climate science, environmental science, agriculture, all of those things. And planetary sciences, astrophysics, heliophysics, and all the physics and computer science literature that supports all of that. So right now we have like 30 million records. Astro, as you can see, is only a tenth of it. So we're rapidly expanding. And about half of them have full text records, which means that even though they may be behind paywalls at different publishers, our search can access the full text, which is really, really powerful. And we have about 300 million citations, and about 50 billion of them are in the Astro. And we also have community curated bibliographies, meaning that ADS is really used by bibliographic managers at Chandra and Hubble Space Telescope to keep track of all the papers and research outputs that use those instruments' data. And we also have integration with Simbad and NED, which are archives that help you search objects as well. So if a paper has a specific object and that is recognized in NED or Simbad, we will also link back to it. And this is our new website. You can find us at sciexplorer.org. I would urge you, if you are an ADS user, please try out SciX and let us know what you think about it. And if you are not an ADS or SciX user, still do, please try SciX. It's really, really awesome. And as I was saying, as part of growing into this huge system, we have truly become more than just a digital library, which means we are right now, since we have all the words ever published in astronomy and now in other sciences, we're doing a lot with AI ML initiatives. And just some guiding principles. Accuracy. So one of the reasons people come to ADS over other search engines is because it is curated, which means it is trustworthy. You don't have to think twice about the source of the data. Whatever you find on ADS, you can really trust. So we're kind of really adamant, if you will, on applying that to the AI ML initiatives as well. Which means that right now we're very careful and a little, we hold back a lot before we release any kind of AI ML features because we don't want to put anything out there that has hallucinations or any of the anything that won't produce 100% reliable results. And privacy is very important to us. We don't intend on harvesting personal information, email addresses, affiliations, any of that. And respect. So we have publisher agreements for all the publishers that allow us to ingest their content into ADS and SciX. So everything that we do is within the confines of that publisher agreements, and we also kind of monitor our API usage to see if there are any third-party, external applications that are kind of trying to circumvent those publisher agreements. And we do our best to do responsible use of AI per the Smithsonian's guidelines. All right, so kind of broadly speaking, the categories of things we work on are data sets and models, which are expert curated both by people trained in curatorial sciences, but also trained in the actual science. So we have earth scientists, astrophysicists, planetary scientists on our team. And everything that we do is open source, open access, open API, open everything. And we have permissive licensing. We have a couple of data enrichment pipelines that I will talk about that use our data sets and models. And we're experimenting with data discovery. And this is the thing that we haven't exposed to the public yet. And I'll give you a glimpse of why. All right, so let's start with the language models. The first one that we created was AstroBird, which was essentially the goal was to provide automated enrichment services, so similar to kind of object detection that SIMBAD and NED does, but with a much broader scope. And it is just a language model that is tailored to astrophysics. It was built on the technology of BERT and SciBird, and it's that kind of foundational in the sense that it's once trained, it can be used for multiple other things, not just entity labeling. It's a 110 million parameter encoder model based on BERT, and it was trained on an astronomy corpus using mass language modeling and next sentence prediction objective. And I'll talk about the MER, I'll talk about the deal model, but basically as like a token classification head on top of the base model that is really fine-tuned on deal. I'll tell you what that is in a bit. But here's a table from the release paper that shows that based on all the different models, almost all metrics, the AstroBird beat all metrics for that deal task, which I will talk about in just a second. But before that, it is publicly available for everyone to use. We have tutorials, we have demos, we have all the versioning, all the documentation. And it was trained on about 400,000 astronomy documents, and everything is open source. And just to back up a little bit for named entity recognition, these are kind of the broad categories of things that are of interest to the astronomy community. Specifically, like when you read a paper and you see entities, which are just, actual, it can be an object. So they can be persons, organizations, a celestial object, an observatory, a telescope, a software, a model, a data set, an institution. So all of these things in the context of literature, obviously, we would like to disambiguate. And so to evaluate how AstroBird performs with named entity recognition, we created the DEAL challenge, which was detecting entities in astrophysical literature. It was part of a 2022 workshop. And we challenged participants to build labeling systems. And as you can see over here, the labeling is it's picking out every entity or object over here and cataloging them as persons, data sets, databases, archives, and such. And as I showed you earlier, for this particular task and this particular data set, AstroBird beat BERT and SciBird and the other models in all kinds of scoring baselines. And it was really neat. And we have gone and used this in our production software for planetary features identification. This was the first use case that we did of it. So automatically we try to classify papers and tag them as if they are talking about a specific planet or a feature on the planet. So the paper, so this is kind of the pipeline schematic, which does this NER step. And then after the NER step, it builds a whole knowledge graph of all the different objects and the connections between the different objects. And this LLM chat score is based on AstroBert, which is trying to disambiguate between people, objects, features. For example, here there's a planetary feature for Mars craters, and there is one of the craters in Mars called Victoria, which is a very popular name. It is also a place in many, actually, we have multiple Victorias across the world. So the pipeline then goes in and tries to figure out if the Victoria mentioned in the paper is the Victoria of the crater Mars, Mars's crater, or if it is a different type of Victoria. And then you would actually be able to search. So if you were doing research on Mars or any of its craters or its volcanoes or Jupiter's moons, you'd actually be able to search for that very specific object, for papers that talk about that very specific feature or object. Because otherwise, if you would just search for it, you would get like textual matches, all types of Victorias or Gales. All right, so the next model that we have built in-house is called Indus. It's a 125 million parameter Roberta model. This is developed in partnership with the NASA Science Mission Directorate and IBM, who worked with us at SciX and some other groups. And it is an encoder trained on SMD corpus. So the SMD corpus is basically papers that cover the entire NASA Science Mission Directorate, which is Earth Science, Planetary Sciences, Helio, and Astrophysics, and biological and physical sciences, so NASA-funded biological and physical sciences. And it was really fine-tuned for semantic search applications. It was released in May 2024. And we tested this for recall for a small set of a test set that was curated by NASA subject matter experts, and in this kind of beat all of them, which was exciting. And we also recently, earlier this year, got awarded a NASA Agency Group Achievement Award for this, along with some other AI for Science projects, which was very exciting. And for us right now in production, we're trying to use Indus for classifying records in SciX. So now that we have become interdisciplinary, we would like to actually go into all the papers and classify them as belonging to astro, planetary, helio, physics, earth science, physics, or other. And it's actually a little more complicated than it sounds, because papers can be multidisciplinary, journals are multidisciplinary, people work on multidisciplinary research. So it is, and some papers truly do belong in multiple categories. So it's not as straightforward as one may think. So we are using Indus to create these classifications. And basically the idea is to allow improved search relevancy. So if you are searching as an astronomer for astronomy-related content, we want to show you the papers that would make more sense, because seismology means something different in an astronomy context versus an earth science context. And so having those collections set will help us improve your search experience. And right now it just uses language model classification, and that's our V1. And once we get that down, we want to include like journal heuristics, citation graphs, author networks, stuff like that, to really further disambiguate which discipline a specific paper belongs to. We're using the Indus model right now, and we're right now trying to reclassify. So planetary sciences and heliophysics was kind of unofficially always part of ADS, because there are journals, like a lot of the AAS journals, for example, like just publish planetary and helio content, but we didn't have a formal collection for them. You can't search for them separately. So we're trying to just go into the astronomy collection and divvy them up as pure astronomy, planetary, and helio right now. And the next model that we're working on is KLIS, the Keyword AI Labeler at SciX. So we're starting with the Unified Astronomy Thesaurus, which is an open source ontology of astronomy concepts. So you can see here, this is an example of UAT concept. So you have this high energy astrophysics parent. And when you expand that, you have all these different high energy concepts, which have their own children, and it kind of goes on further. So as with any ontology, its purpose is to better classify things, and we use it to better search for things, for papers, and make them more relevant to your searches. For that, we have trained KLIS, a Roberta-based encoder-only transformer model, about 425,000 astronomy papers it's trained on. And these papers are all selected such that the authors and publishers have provided UAT keywords. So if, as many of you are probably aware that when you go to a AAS journal and try to submit a paper, it will ask you to provide UAT keywords. It's a required field of when you submit. So we have taken all of those author assigned UAT keywords and then done our downstream training. And KLIS is essentially kind of a successor offshoot of a fork of Indus. It's basically a fully trained model, but we started from Indus, the previous model's weights. And everything's available publicly on Hugging Face. We even have this little demo if you're interested. If you're working on a paper and you're trying to submit it soon, I would encourage you to go as a Jupyter notebook and just like put in your abstract and see what are the top keywords it recommends. And I guess let us know if it works or if it's giving you something completely egregious. So our evaluation process right now is involving a working group and very manual. So you have the input, the title and abstract, and beyond the title and abstract, it's a little harder just because the chunking of text gets a little messy if you try to use the full text. But we output keywords and their scores. We take the top 5-10 of those, and then we compare them to author assigned keywords. So now for this example, you see that the author is assigned radio transient sources, and our model has a very, very high prediction score for radio transient sources. However, it also has a non-negligible score for compact binary stars. And this is kind of getting to one of the problems or one of the challenges we're facing right now with this is when authors upload keywords, one, they're not necessarily complete. Like we don't go through all 2,000 keywords that are there in the UAT and pick the best ones. We pick generic, maybe mostly high level. They're mostly skewed towards high level keywords. That means by definition, since we're trying to give you the best complete set of keywords that apply to your abstract, we are going to give you more keywords than the author assigned. So our training itself is a little complicated because we can't just do a one-to-one match and call it a day. We're by default going to assign more keywords than the author provided are. So the working group we have a working group working on this with experts in both astronomy and some experience in curatorial sciences. And the consensus in all of this is that it's working pretty well, but there's also a very strong signal of false positives. And sometimes it picks up things that don't make any sense given the context. And that just comes down to these three things, is that author practices are kind of ununiform because a lot of papers in astronomy, for example, are tagged with the topmost level keyword called observational astronomy, which means that like 90% of all papers would be under the observational astronomy. It's not a meaningful keyword. Or sometimes it's like way too specific that, it's very hard to apply to other things. So, and that brings us to uneven coverage. There are some keywords with a lot of papers, and there are some keywords with none. And we uncovered an issue with our training set with certain keywords, like for example, the word magnitude. in astronomy means something related to brightness. And in earth sciences means something related to earthquakes. So obviously, those earth science records should not be tagged with the UAT keyword astronomy, with the UAT keyword magnitude. But that also ties into the previous pipeline we were talking about of classifying these records properly in their specific discipline, which will then help us actually assign astronomy keywords only to astronomy papers. And yeah, so this is what we're working on. And just a little quick screenshot demo. So if you go to the SciX abstract page, if it's an astronomy paper, you will see these keywords that are assigned by the authors or given to us by the publisher. And we also have the generated UAT keywords here. And if you click on the little caret, you will see the broader terms and then the narrower terms and related. Like, so if there are parallel terms, you will see them. And if you click on that little search icon, you can see all the other papers that have been tagged with the same keyword. So if you're kind of in your literature discovery phase of specific types of objects or concepts, really useful. So it looks like a simple little field in our website, but there's a lot of stuff happening behind it. And yes, and also on the search result side, you'll see the keywords facet down there, and that's the publisher provided keywords. But the UAT specifically will show up for astronomy papers that we can also search or filter to specific topics or UAT keywords from there. So it's right now live on our website. You can try it out, and if any of your papers have the wrong UAT keywords, please let us know and we will put that into our reinforcement learning step. All right, and also, like, if you actually want to search from the search bar itself with the UAT keywords, we also do a little autocomplete with the definition to help you, and alternate labels, because every ontology has lots of synonyms in different ways, so we will suggest the similar labels. And that was all for models and pipelines, but now let us talk about our internal AI experiments. This has been most in the data discovery type of thing. So one, ADS is a database. So the best results that you will have is if you do structured queries. If you do author : somebody's name, you will actually have the best result. You can do just a free fielded search, but it's not as powerful as a proper fielded search. But of course, this is not intuitive to anybody that is not me or my other 20 colleagues. So we were trying to experiment with a chat assistant. So basically to translate your query from natural language into Solar is the database system that we use, structured query. And it was actually not terrible. This was just basically a custom GPT that was fed with all of our API and search documentation. And it took this, like, what paper was Alberto Akamazi on that talked about embeddings, and then it searches, translates that to author Alberto Akamazi. Abstract should have the word embeddings, and these are the fields that will return, and it does a pretty decent job of that. So we haven't exposed this for actually logistical reasons. It actually worked pretty well, but I think once the Harvard AI sandbox was introduced, ChatGPT licenses were the institutional license we could no longer pay for it. That's the reason that it's purely logistical, but we are trying to look for a way to move this away from the custom GPT into some other hosting mechanism. And the other piece is that with the traffic that we get, which is about 60,000 daily users, if we start exposing this, we would blow through our entire year's budget on API calls. So that's right now our limiting factors. And Similarly, other things like how do you navigate the help pages with, so do retrieval augmented generation with our help page text, and our API code generator was actually pretty useful. So if I didn't already mention it, we have an open API to use. We have all the documentation. It is a great tool. You can basically have all of SciX's functionality and even more than the UI actually via API. And we were experimenting with a little custom GPT that could, take whatever use case you had and build you a Python script with it. And worked pretty well, but same thing of logistics. And of course, like I was talking about the accuracy piece, and our worry with any generative AI type thing right now is the accuracy. If we can't guarantee that it will not hallucinate, then we don't want to have it. So this was another cool, fun experiment internally. It was called SciX Brain. It was a language model test bed. And basically, like, just really something that does RAG with ADS queries and the API calls. So truly, a RAG chatbot for ADS. And it worked, again, pretty well, but our bigger worry with this was hallucinations, that we can't 100% guarantee everything that we'll say. Again, at the search volume that goes through us every day, even a 1% error rate is something that people will immediately flag. And we lose that kind of accuracy edge that we pride ourselves on. So hopefully with future, future work, and also we have to look at the logistics of how to reduce cost on this for our volume, but we are hoping to release something like this just be really valuable for people in the astro community. And we also have several collaborations. So we collaborate with Pavlos Protopapas at the Harvard School of Engineering, and his students are working on several projects. For example, a citation predictor. So based on your paper and based on the citation network that ADS or SciX will provide you, what citations can it dig out that would be helpful for your paper. SciX Labs is kind of like this sandbox website framework to host like pilot projects and just experimental things would be really cool. So that would be a cool way of us serving these experimental things we're working on, but without it being on the main website. And we have co-organized a bunch of workshops and working on lots of research collaborations in the AI ML space. And if any of you are interested, these two, the WASP 2025 is, the abstracts are, deadline is still next week. And the language AI, the space sciences workshop and space telescope is in March. You also check it out. The actual challenges are also really fun. And that's all I have today.
Any questions?
I was curious about the testing of this system. You have a group of testers, right? Do you have any plans of involving the CFA at large in this? Because it's pretty good science-based.
Yes, 100%. I mean, we would be ecstatic if somebody wants to volunteer to test for us.
But I don't see more than volunteer. Just go to the director and say,
yeah. Ideally, it would be great. And I think something that we had floated around, and maybe we'll see if there's interest for this, is to have like a little like, you know how you have like those wiki hack days where you just all sit in a room together and go fix Wikipedia? But like stuff like that would be really fun. Like if people got into a room and just everyone was there for an hour and they just started tagging this. It's unfortunate that, like I said, because of the challenge of this task where your expected outputs are naturally, they're by definition going to be different from your training set. Getting human power to to actually take the time and do manual annotation or just say yay nay is been our biggest blocker. So yeah, so if anyone's interested and you think this is a fun project, let us know. We will be so happy to have you. And of course, we'll provide credit and all of those things when these things actually go live and if those papers are released. But yeah, that would be a cool thing. We could all just sit together and classify papers for an hour. Fun project.
Be sure that you were identifying what
Oh, yeah,
it's not underscored.
that is under, no, this is just, so it is on Hugging Face. If you go to Hugging Face, yeah, if you go to Hugging Face, you will see the Jupyter. This is just the file actually, but it is hyperlinked. So if I get to share the slides, then then you will get a chance to- yeah. Yes.
Peter?
So with the keywords, I feel like one of the benefits of AI language model systems is instead of having to come up with this like, partition space of topics, you have these n-dimensional vectors fundamentally that you can do, I don't have to wait for someone to create a keyword to define the category of papers that I care about. We can, do some kind of dot product to search for them directly. So I mean, like I used to be on the UAT steering committee, so I appreciate a lot and all the work that goes into it, but also it kind of feels like, is this even, if we have language models, like should we even be pushing on this or should we be trying to build a user experience that avoids the need to like come up with this discrete partition?
Yeah. Yeah, see, that's a great point, but in my head, and this may be maybe evolving as technology evolves, but in my head, it's not an either or. I think it's a board leverage both. So, because even when you're doing semantic search and things, when you if you do have a keyword vector, it doesn't hurt. It actually makes those kind of embedding space semantic searches, I think, even better, that you can cluster them in different ways. So I don't see it as an either or. I think it's, and I think that's because semantic search is something where we are like natural language based semantic search or embedding space searches is something that we're actively working on right now. Our blocker for that, again, logistics is search volume and the number of records we have. We have a 30 million corpus. It's not a small task to make such a big semantic search and then have it do different things on the fly. And also, like I said, the cost to do API calls, especially if you're doing it, for search, is very high, which is why this is kind of a stopgap in between. It's more for, logistics of what is practical at such a high wall. But I also think that once these keywords and stuff are there, in my mind, the way I envision it is only going to help those embedding vectors to just cluster better in whatever dimension.
So yeah, I guess that with all these queries that involve a lot of cross references, like whatever bucket we are using it to call like the graph queries, also, which kind of bucket, if they are using to store all these information calculations, like like
What kind of backend?
yeah, like
search?
what kind of database backend that you are using, like.
Yeah, so we have a Solar search system right now. So it does work on, so there are certain things that are just, Solar is I think, just a protocol essentially, or a system. But there are some searches that work purely on like text matching. And there are some things like if you search for citations and stuff, we have full citation graphs on the back end that help connect you through different pathways. So if you're looking for like similar papers or trending papers, we'll actually use the full citation graph on the back end to recommend papers that are similar to whatever you're reading, and it's not just a text-based thing. So it's kind of a combination of both.
Yeah, so like, do you know which kind of software is it that stores these graph relations? because I get that when you query, give me papers related to this one, and then you rate them by, let's say, similarity or
Sure.
closeness or
Yeah.
whatever. And you are running some.
Yeah,
query.
and that's solar, SOLR, that's the,
Solid.
yeah, that's the technology that is powering our search.
About the ensuring there's no hallucination. With my limited knowledge about large language model, it seems to be this somewhat fundamental issue with the large language model. What is the strategy for your system to ensure? I mean, unless there's a fundamental issue is resolved, and there may be always some lingering issue, there will be a hallucination, but how do you handle that?
Yeah, so I think that's kind of why we are doing all these augment and enrichment, so that again, ultimately, again, in my mind, it is like when you do a search, instead of having it be a fully unstructured, go search all the text in the search results, it would be something like your query gets actually translated or broken up into all these different metadata specific searches. And that will help fine tune the results a little bit so that the language model itself is like the retrieval part of it. We can try and control as much, but then it's just the interpretation part of it is so we're just reducing the, what's the word for it?
Variables.
Yes, we're reducing the variables in which, like, all the free variables, right? So like on the retrieval side, just not just with retrieval augmented generation, but also like by kind of having this intermediate step to use all these other metadata to structure your query. So to the large language model, you give a very structured query, and then it's just that last piece of interpretation that we can't control, but we're trying. I don't think we have a solution for that yet, but the language models have been getting better rapidly. And if we ever expose any of this, we are quite adamant on like putting inline citations. So not just like, here's a blob of text and here's the citations, here's the sources that I used for it, but like, here is quote some information, and that quote came from this paper. So like that's something that we would try to do. Again, it's all in the works, but in our mind, that's the goal. The goal is to attribute everything to a source. And on the retrieval side, not just lock down the input, but also kind of try to use all these all the database facets in metadata to actually give the large language model a more structured query, essentially. Yeah, and we don't know, and also like other parties, resources, both usage and developers. So we don't know when we will be able to expose this, but also maybe something like the SciX Labs platform I was telling you about, that maybe it would be okay to have some kind of sandbox playground space where the people using it are expecting that this is not going to be perfect, but it's a starting point for them to use their research.
Great, thank you.
Other questions? So I did have one question for you. I didn't see, so actually, I guess I'm curious, is there any plans to do multimodal? Cause to me, like, you got all these bots that have like the, meat of it.
Yeah.
Is there any plans to do
I
that?
mean, there is, what I can tell you is there's definitely a dream to do that.
Yeah.
We would love to search figures and tables and all those things and figure captions, really, because most papers you see the figures, read the figure captions, and abstracting conclusions, you kind of figured out what the entire paper is about. We would ideally love to do that, but it is something that is not currently in our sites, just because there's so much other stuff happening.
Yeah.
And also we don't have the resources, but if there were people that wanted to partner with us to try, and because we definitely, like you said, like, since we have access to the full text, we do have access to the figures, and there's some other engineering on the back end that we're working on, a full text pipeline. to be able to easily access the text, the captions, the tables, the notes of tables, the figures themselves. But once we have that, this would ultimately be incredible if you could just search figures. That's crazy.
Be nice if people shared the raw data too, right? That's part
Yes.
of publishing paper.
Yeah. There are, yeah. So it would, like I said, we have the dream exists, but right now we don't have the resources to get there at this time.
Any last questions? So you're here, your office is right down the hallway
Yes,
here,
yeah.
so if anyone wants to talk to them about that. I was stop by, email,
Yeah,
email
absolutely.
first.
Yeah, I mean, email, stop by, whatever it is, I'm happy to talk, chat, and answer questions.
And thank you once again. Thank you.